Now we continue example number 12. Okay, we have this is the question about the dielectric partially filled capacitor. So we have a dielectric that is partially filled, half filled. A parallel plate capacitor has a plate area. The plate area is given, that is 250 centimeters square. So first we have to write the given information. So area A is 250 centimeters square. So in order to convert centimeter into meter, we have to multiply with the 10 raised to the power minus 4 meters square. So area is given, and plate separation D is 2.0 into 10 raised to the power minus 3 meter. D is 2.0 millimeter. Okay, the voltage V is given between the plate, that is 150 volt. 150 volts. Okay. And then the battery is disconnected. The charge Q on the plate is then down changed. The dielectric sheet K is 3.5 of same area, but thickness L is equal to 1.0. So that this thickness of this sheet is 1 millimeter, that is inserted between the plates. Okay. So first find the initial capacitance when the air is filled. So initial capacitance is, we use simple formula, C is equal to epsilon naught A over D, because area is given 2.5 10 to the minus 2, 250 10 to the minus 4, or 2.5 10 to the minus 2, the same thing. Okay, and the D separation is 2 millimeters. So we get 111 picofarad when the space, there is no medium between the plates, there is no medium between the plates. So this is for A part. We use simple C is equal to epsilon naught A over D, simple formula. And B is the B for the B part, charge on the each plate before the dielectric inserted. So the before the dielectric inserted the charge. So Q is equal to C naught V. We already know the C naught is the without medium, that is 111 picofarad, 111 or 1.11 to the minus 10 farad, which is multiplied by V naught is 150. 111 pico mean 111 into 10 raised to the power of minus 12. That can be right as 1 point, we can write it as 1.11 to the power minus 10 farad. Then we get the Q. So these A and B for the vacuum. Okay, for the part C, charge induced on each plate when the dielectric. So when the dielectric is introduced, so that we need to find the charge. So the Q induced is, we know that in the previous we discussed detail, the Q induced is equal to Q into 1 minus 1 over K. So the Q is given, Q is, we know that the Q, that is 1.76 to the power minus 8, and 1 minus 1 over K is 3.5. It is also given, so we can find 1.19 to the power minus 8. So for the part D, the electric field space between the plates, so we need to find the electric field between. So E is equal to Q over A epsilon naught. Q over A epsilon naught. This is formula for E. But how we find this formula? Because we know that E is, we can derive this formula. Intensity, according to Gauss' law, intensity is equal to sigma over epsilon naught, and sigma is we know that charge per unit area, Q over A epsilon naught, we know that. So we use this directly, this equation, Q over A epsilon naught. So Q is 1.6 to the power minus 8, that is equal to 1.6 to the power minus 8, and epsilon naught is 8.85 to the power minus 12, and the area is 2.5 to the power minus 2. That gives us 7.5 to the power 4 volt per meter. So in the part E, the electric field between the dielectric, so we need to find the electric field for dielectric. So ED is equal to E naught over K. So E naught is already, we find 7.5 to the power minus 4 divided by K is 3.5, we get ED. In the F, we need to find the potential difference between the, after the dielectric is added. So the potential difference V is equal to minus E dot dl. We use this formula. Okay, so in order to get this E dot dl, so we have to find E, as we know that E is equal to, V is equal to minus E dot dl. So for example, this is some equation star. So E is equal to, we know that E is equal to E naught plus E naught plus ED. In the previous case, we already know from this E naught plus ED. So we put this value in this V above formula, E is equal to minus E naught plus ED dot dl. Okay, Now we know that the dl can be multiplied by this factor E naught minus E naught dot dl plus ed into d dot dl. Okay, so we know that the dot product is edl minus edl e d minus l dl integral plus ed integral dl. So if we take the integration from l, upper limit is d, lower limit is l to d. So we took the l to d, because we know that this is the length 1 millimeter, 1 to 2 millimeter, 1 to 2 millimeter. We took integration from l to d, we took integration l to d, so that minus e, this is l, lower limit l, upper limit d, plus ed, lower limit l, lower limit. So for the ed, because the dielectric, the length is l totally from 0 to l, so that the length is from 0 to l. So we can write here minus e upper limit d minus l plus ed, so l minus 0. So we are left with the same formula, that v is equal to minus e d minus l plus e into length l. So this is the formula that we need, E naught d minus l plus E d l. Okay, so now we know that the minus sign can be removed by using the taking the cos of 180, because you know that dot product is E d l cos of 180, because the angle between electric field intensity and length element is 180. So cos 180, it will give us the plus sign on both sides, plus. Why it is cos 180? Because length element electric field intensity is going from this way, from positive to negative, and but length element is from this way, so that's why we can take 180 degrees. So this negative sign can be removed, it will give us plus. Okay, now we solve this E into d minus l plus l over k. So ed is, we know that ed is equal to E naught over k, ed is equal to E naught over k. So we can find we took a E naught common, so we are left with the E d minus l plus l over k. Now we put all the values and we get voltage 96.4, and we use C is equal to Q over V in order to find the capacitance ability. This voltage is same, but we put the value of the Q. Okay, thank you.